Hello, and welcome to Quiet Learning for Sleep. This is your peaceful space to unwind, to let go of the day, and to drift into deep, restful sleep while learning softly about our universe. Here, we take gentle journeys through calm ideas, stories from science and nature, space and time, history and life, all whispered at a soft pace, without rush, without noise, and without pressure. You do not need to focus or remember anything. This is learning the quiet way, where your mind floats and drifts and rests, while curiosity stays softly awake in the background. If you'd like, before you get comfortable, you can subscribe and gently like this video. Doing it now means you won't forget later, and it helps others like you find this calm, sleepy corner of the world. Now, allow your breath to slow just a little. Let your shoulders relax. Let your thoughts soften, like clouds drifting across a calm evening sky. There is nowhere you need to go, nothing you need to do, and nothing expected from you here. This time belongs to rest, comfort, and gentle curiosity. And if you drift to sleep along the way, that is not only allowed, it is welcome. So settle in, let yourself melt into stillness, and allow your mind to float quietly as we begin. Close your eyes and imagine yourself drifting through a gentle, endless darkness. A darkness not empty, but soft and welcoming, filled with distant light and quiet motion. As your breath slows, a warm glow rises ahead of you. The sun, the great lantern at the center of our solar system. Its light washes gently over your thoughts, and with each exhale, you drift a little closer to the beginning of everything. The sun formed more than 4.5 billion years ago, when a vast cloud of gas and dust collapsed under its own weight. As it compressed, it grew hotter and brighter until nuclear fire ignited in its core. Around this newborn star, leftover material flattened into a swirling disk. From that disk, tiny grains gathered into pebbles, pebbles into stones, stones into worlds. Every planet, every moon, every wandering asteroid is made of the same ancient dust, reshaped by time and gravity into the architecture of our cosmic home. As you float in this vast stillness, you begin to sense the structure of the solar system surrounding you. The inner planets, Mercury, Venus, Earth, and Mars, form a compact family of rocky spheres orbiting close to the sun. They are warm, solid, and shaped by metals and stone. Their surfaces hold memories carved in craters and valleys, in volcanoes and dried riverbeds. They are worlds of texture, worlds with surfaces you could touch, worlds that once shared the same fiery beginning, but grew into very different lives. Farther out, beyond a drifting band of asteroids, lie the giants, Jupiter and Saturn, immense, powerful, made mostly of hydrogen and helium. They are not places you could stand, but immense atmospheres stacked in layers, swirling with storms older than human history. Beyond them, Uranus and Neptune spin in the cold twilight, pale blue worlds filled with methane, water, and exotic forms of ice found nowhere on Earth. These outer planets drift gracefully in the deep cold, each one telling a quieter, slower story than the worlds of stone closer to the sun. The solar system is held together by gravity, the invisible thread woven through every orbit, every moon, every drifting comet. Gravity shapes the pathways of planets, pulling them into smooth ellipses around the sun. It guides each world's rhythm, the length of its days, the sweep of its seasons, the tilt of its axis, the way its moons dance around it. every object you can imagine, from the largest planet to the smallest grain of dust, moves according to this ancient, silent law. A day on each planet tells a different story. Some worlds spin quickly, turning day into night in only a few hours. Others rotate so slowly that a single sunrise might last months. A year, the time a planet takes to complete an orbit, varies wildly too. Mercury finishes its journey around the sun in just 88 Earth days. Neptune needs 165 years to complete the same path. Time stretches and folds differently on every world, each planet ticking to its own gentle rhythm. Temperature follows this cosmic rhythm as well. Near the sun, worlds scorch under relentless light. Farther away, planets sink into temperatures colder than anything found naturally on Earth. Some worlds swing between extremes, burning during the day, freezing at night. Others maintain a constant furnace-like heat, or a steady, bitter chill. In these differences, you can feel how sunlight and distance shape the nature of every world, giving each its own climate, its own personality. Atmospheres also set these worlds apart. Some planets have thick blankets of gas, swirling with storms, trapping heat, or glowing with icy haze. Others have almost no air at all, silent, exposed landscapes where nothing protects the surface from the raw light of the sun. Earth's atmosphere, a careful balance of nitrogen, oxygen, and water vapor, is a rare gift in the solar system. It softens sunlight, carries clouds and winds, and shelters life in all its forms. In contrast, Venus's thick atmosphere traps heat until the planet becomes a world of fire, while Mars's thin air lets warmth escape, leaving deserts of frozen soil and ancient valleys. Water, the ingredient we associate most with life, appears throughout the solar system in surprising ways. On Earth, it flows across continents and pools in vast oceans. On Mars, it hides as ice beneath the soil and in polar caps. On some moons of Jupiter and Saturn, enormous oceans lie beneath shells of ice, warmed by tidal forces and geological activity. Even Mercury, scorched and airless, contains frozen water in craters the sun can never reach. Water exists everywhere in different forms, hinting that life, too, might not be as rare as we once believed. And then, there is the question of what makes a planet. A planet. Shape is one answer. Gravity must mold it into a sphere. Orbit is another. It must circle the sun, and it must be massive enough to clear its path of debris, dominating its orbit. This final rule is why worlds like Pluto, Eris, Haumea, and Makemake are called dwarf planets. They orbit the sun. They are spherical. They are beautiful and mysterious, but they share their region with many neighbors and have not swept the space around them clean. Even so, these distant worlds hold stories every bit as fascinating as the 8 major planets. If you listen closely, drifting in this calm, cosmic silence, you can almost feel the solar system breathing around you, the sun pulsing with warmth, the planets gliding along invisible rails of gravity, the smaller bodies, comets, asteroids, icy fragments, weaving through the spaces between worlds, like tiny messengers carrying memories of the past. Every orbit, every rotation, every drifting particle contributes to an ancient harmony that has played for billions of years. As your awareness settles deeper into this gentle journey, let yourself feel the reassuring order of it all. The solar system is vast, but not chaotic. It is old, but not stagnant. It is dynamic, balanced, peaceful, a grand clockwork turning in slow, elegant silence, and you are floating at its center, watching sunlight spill across planets of fire, ice, stone, and storm. Soon, we will travel to the first world closest to the sun, a small, cratered planet, scorched by daylight and frozen by night. But for now, rest in the calm understanding that every world has its place, every orbit its purpose, and every planet its story. Your journey through the solar system is only beginning. As you drift gently away from the wide, architectural view of the solar system, your consciousness narrows, focusing on a single small world circling closest to the sun. Mercury, a quiet, cratered sphere wrapped in ancient silence. It does not shine with the dramatic beauty of gas giants or the blue glow of Earth. Instead, it remains modest and gray, almost shy in its simplicity. And yet, this little planet carries stories older than any world, except the sun itself. Approaching Mercury feels like approaching a relic, a planetary fossil preserved almost exactly as it was billions of years ago. Its surface is scarred and rugged, shaped not by wind or rain, but by the constant rain of meteorites long ago. Every crater, every ridge, every frozen splash of ancient lava captures a moment of the early solar system. There is no atmosphere thick enough to erase these memories, no rain to soften their edges, no flowing water to reshape the land. Time here does not heal. It only accumulates. The sun hangs enormous and brilliant in Mercury's sky. From this close distance, sunlight feels raw and unfiltered. During the long Mercurian day, a day that lasts an astonishing 176 Earth days, temperatures soar to around 430 degrees Celsius. The rocks glow with heat, shimmering slightly as the surface radiates energy back into space. Yet when Mercury turns its face away from the sun, the same surface plunges into a deep freeze of around minus 180 degrees. No other planet experiences such violent contrast between day and night. It is a world of extremes, switching from furnace to freezer in slow, sweeping cycles. If a 70-kilogram person were standing on Mercury, they would weigh just about 26 kilograms. They would feel light, almost buoyant, as though gravity had eased its grip. This gentle pull comes from Mercury's small size, the smallest of the 8 planets. But despite this inviting lightness, a human could not survive here. The air is barely present, only a fragile exosphere made of sodium, oxygen, hydrogen, and a scattering of other atoms. It is so thin that individual molecules drift for thousands of kilometers before colliding with another. A single breath of air would not exist long enough to inhale. Survival time, without protection, would be measured in seconds. Mercury's orbit is fast, the fastest in the solar system. It loops around the sun in just 88 Earth days, yet its rotation is slow, creating a strange pattern known as a 3-to-2 spin-orbit resonance. For every 3 times Mercury rotates on its axis, it completes exactly 2 orbits around the sun. This rhythmic lock creates unusual sunrises, unusual shadows, and a day that stretches on for months. Standing on the surface, you could watch the sunrise, pause, reverse direction slightly, pause again, and then continue forward. A celestial dance, created by gravitational mathematics, that feels almost dreamlike. Despite being scorched by sunlight, Mercury hides surprising coldness in places where the sun never shines. At its poles, deep inside craters, lie floors so permanently shadowed that they have not seen sunlight in billions of years. Temperatures here remain unimaginably cold. and within these frozen pockets, radar observations have revealed deposits of water ice. Pure, ancient, and untouched, these frozen reservoirs hint at a complex history, one where comets, asteroids, or perhaps even Mercury's own internal processes delivered water long ago, preserving it in nature's coldest vaults. Imagine drifting above such a crater, looking down into a darkness so complete it feels bottomless. The sunlight cannot reach these depths. It skims across the crater's rim and slips away into space. At the bottom, the ice gleams faintly under your gaze, illuminated not by the sun, but by the gentle reflection from your drifting viewpoint. It is a soft, silent reminder that even in the hottest places, cold can survive, if only it finds the right shadows. Mercury's surface is not only cratered, it is also wrinkled. Giant, curved cliffs known as lobat scarps slice across the planet like scars. These cliffs formed when Mercury's interior cooled and contracted, causing the entire crust to buckle. Imagine a dried apple shrinking in size, its skin folded and creasing. Mercury experienced something similar, except the apple was a world, and the shrinking crust moved mountains. Some of these scarps stretch hundreds of kilometers long and rise several kilometers tall, dividing the surface into vast, jumbled landscapes. Floating slowly over these scarps, you sense the weight of geological time pressing through the silence. These features are not the results of sudden, violent catastrophe, but of slow, relentless cooling over billions of years. Mercury shrank as it aged, tightening like a quiet stone that sighs inward, pulling its own edges close. No other planet in our solar system has experienced this kind of global contraction so dramatically. There is no wind here to move dust across the plains, no atmosphere to create weather, no rain to carve valleys or rivers. Mercury's landscape is frozen in place, shaped only by sunlight, shadow, and the rare impact of a meteorite. Every crater remains almost exactly as it was formed. Some are shallow and broad, remnants of ancient collisions. Others are deep and sharp, younger scars made by faster, harder strikes. Each one tells a quiet story, a whisper of something that arrived from far away and changed the surface forever. If you drift near the horizon, you would notice that Mercury has no soft blue glow like Earth, no atmospheric halo bending the sunlight. The boundary between rock and space is sharp, almost sudden. One step forward would place you under the full force of the sun, and one step backward would plunge you into near total darkness. Without air to scatter color, the sky is black even at noon. The stars remain visible, forming a still background behind the blazing sun, a surreal combination found only on airless worlds. Despite its harshness, Mercury possesses a form of beauty, a beauty born from endurance. It is a world that has survived close to the sun without being destroyed, a world that has held onto shadows cold enough to preserve ice while enduring days hot enough to melt metal. A world whose quiet presence reminds us that survival comes in many forms, even in the most unforgiving environments. As your awareness drifts above this scorched planet, feel the calm of its unchanging nature. Mercury does not pretend to be anything other than what it is. It simply circles the sun, again and again, quietly reflecting light into space. Nothing rushes here. Nothing argues or resists. It is a world that accepts extremes, carries ancient scars, and continues to move with steady, unwavering rhythm. As you drift through the gentle darkness of space, the next world comes into view. A pale golden sphere, glowing softly beneath a thick, unbroken layer of clouds. Venus looks peaceful from afar, wrapped in a calm, pearly light. The smoothness of its atmosphere hides every detail of its surface, giving it an almost serene appearance. But beneath this quiet exterior lies one of the most hostile environments in the solar system. A world of relentless heat, overwhelming pressure, and chemical storms unlike anything found on Earth. Venus is nearly the same size as our home planet, and for a long time, scientists imagined it might be Earth's twin, perhaps even lush, warm, and full of oceans in its ancient past. But approaching Venus reveals a completely different reality. Its clouds are not made of water vapor, but of sulfuric acid, swirling through the atmosphere in dense, reflective sheets. The sunlight that filters through them is weak and distorted, casting a muted yellow glow over everything. These clouds trap heat so efficiently that the surface becomes a furnace, hotter even than Mercury, despite being much farther from the sun. The temperature at the surface remains nearly constant at around 465 degrees Celsius, day and night, poles and equator. A heat so intense that lead melts, metals soften, and electronic instruments quickly fail. Venus's thick carbon dioxide atmosphere, 90 times the pressure of Earth's, presses down with immense weight. Standing on the surface would feel like being a kilometer underwater, wrapped in a heavy, crushing blanket of gas. A human could not survive even a second here. The pressure would collapse the lungs before the heat had time to burn. And yet, despite this unbearable environment, Venus moves with calm grace. Its rotation is slow and unusual. One Venusian day lasts 243 Earth days, and it spins backwards compared to most other planets. This retrograde rotation means that the sun would appear to rise in the west and set in the east. Though standing on the surface, you would not see it clearly. Only a faint, golden glow shifting through the dense clouds. The length of the day, combined with the depth of the atmosphere, makes Venus a world where time feels stretched and softened, each moment pulled long by heat and haze. A person of 70 kilograms would weigh about 63 kilograms on Venus, almost the same as on Earth. Gravity is familiar here, gentle in its downward pull, but this familiarity is deceptive. The air, thick and hot, blurs every horizon. Distant hills become mere shadows behind yellow mist. Mountains fade into glowing silhouettes. Landmarks dissolve into the atmosphere, as if the planet is reluctant to reveal itself. The surface, when it can be seen through radar mapping and lander images, is covered with volcanic plains, fractured plateaus, and mountains rising from a world built largely by fire. Volcanoes dominate much of Venus. Many are enormous shield volcanoes, spreading across vast regions. Some calderas stretch for hundreds of kilometers. The heat of the planet suggests volcanic activity may still be ongoing, though it happens deep beneath the clouds, where no human eye can directly witness it. Lava flows carve long channels across the surface, some winding like frozen rivers of stone. The planet's crust is fractured, bent into tessellated patterns, as though the world once shifted and stretched under immense internal pressure. The atmosphere above these volcanic landscapes moves with unexpected speed. At the surface, the thick air crawls slowly, offering only gentle breezes. But higher up, the winds accelerate dramatically, circling the planet in a phenomenon known as superrotation. These upper-level winds move faster than 300 kilometers per hour, whipping the clouds around Venus in just a few days. From space, the cloud tops swirl like cream stirred in a bowl, racing far ahead of the planet's slow rotation. The clouds themselves are majestic and terrible at the same time. They are layered, complex, and dense, thick enough to reflect most of the sunlight that reaches them, giving Venus its bright and beautiful appearance in the evening and morning sky. But within these clouds are droplets of sulfuric acid. These droplets form sheets and swaths, drifting through an atmosphere where lightning flashes in brilliant silence. These storms are powerful, though hidden from direct view. The acidic mists erode metal, destroy electronics, and corrode anything that touches them. Beneath the vast cloud deck, the surface pressure builds until it becomes almost unimaginable. Imagine the weight of 10 school buses pressing on every square inch of your body. That is the kind of pressure found on Venus's surface. Machines sent to explore the planet survive only briefly. The Soviet Venera landers, some of the toughest machines ever built for planetary exploration, lasted barely an hour before being overwhelmed by the heat and pressure. Yet in that short time, they managed to send back images, a cracked, rocky landscape, glowing in muted, filtered light, silent and utterly still. Despite its hostility, Venus may once have been gentle. Long ago, billions of years in the past, it might have had oceans of liquid water, warm climates, and perhaps even conditions suitable for early forms of life. But a runaway greenhouse effect, a powerful stretching of natural warming, transformed it into the furnace it is today. As the sun brightened over billions of years, water evaporated, carbon dioxide accumulated, and the planet's atmosphere thickened until stability was impossible. Venus became a cautionary monument to what extreme greenhouse warming can do to a planet. Yet, even in its current state, Venus holds mysteries that soften its harshness. Above the oppressive surface layer, in the higher atmosphere about 50 to 60 kilometers above ground, temperatures and pressures become surprisingly Earth-like. Here, the air is cool enough to permit survival with protective equipment, and the pressure is no greater than what you would experience on a mountaintop. Some scientists believe microbial life could potentially exist in these cloud layers, tiny organisms drifting within acidic droplets or hiding in rare pockets of moisture. Not life as we know it, perhaps, but a reminder that possibility can exist even in the harshest environments. From this distance, floating above the atmosphere, watching the golden light glow and ripple across the clouds, Venus looks peaceful, almost dreamy. The planet has no moons, no companions in its orbit, drifting alone in slow silence. Its brightness in our sky has guided travelers for centuries, appearing as both the morning star and the evening star. It is the third brightest object in the sky after the sun and moon, a beacon of light that has inspired myths, poetry, and wonder. As you observe its soft glow, you might feel a quiet contradiction within Venus. On the outside, it shines with a gentle beauty, a warm candlelight presence in the night. On the inside, it burns with relentless force, shaped by pressure, heat, and chemical storms. It is a planet of paradox, serene from afar, violent up close, a reminder that beauty can hide power, and that stillness can mask unimaginable energy. In the end, Venus asks nothing of you except quiet observation, It is a world that does not invite visitors, that does not soften its harshness or try to imitate Earth. It simply exists in its own way, glowing, swirling, burning, drifting, an ancient twin that took a different path long ago. As you float in silent orbit above its glowing clouds, let the strange calm of Venus settle gently around your thoughts, like a warm light seen through a fogged window, distant and mysterious. You drift through the soft darkness of space until a familiar blue glow rises before you, a world alive with color, motion, and delicate swirls of cloud. Earth, the planet you know most intimately, yet one that becomes surprisingly unfamiliar when viewed from afar. Floating above it, you see continents shaped like ancient puzzle pieces, oceans shimmering in deep shades of blue, and atmospheric patterns curling across the surface, like strokes of white paint. In this quiet perspective, Earth appears peaceful, a gentle beacon in a vast and silent universe. From space, the most striking feature is the abundance of water. More than 70% of Earth's surface is covered in oceans, seas, and lakes. These waters reflect sunlight in soft flashes of blue and silver, moving in endless cycles of evaporation, condensation, and rain. Every cloud drifting beneath you, every wave rolling across the surface, every river winding through land, all are pieces of a grand, continuous breath. Water flows, rises, and returns, shaping landscapes and nurturing life in ways no other planet has managed. Earth's atmosphere spreads over the planet as a thin protective blanket. From your quiet vantage point, it appears like a faint halo, glowing pale blue at the horizon, where sunlight bends through air. This fragile layer contains mostly nitrogen, then oxygen, a gift shaped over billions of years by microbes, plants, and the slow evolution of life. The air carries warmth, scatters sunlight, supports weather, and shields the surface from harmful radiation. Without this atmosphere, Earth would be as bleak and silent as the moon. With it, the planet breathes, hums, and thrives. If you hovered quietly and watched the shadows drift across the surface, you would witness Earth's daily rhythm, a rotation lasting just 24 hours. The planet turns with gentle steadiness, creating sunrise and sunset, shaping rhythms of sleep and activity for every creature alive. This short day, combined with Earth's moderate tilt, creates a balance of seasons. Winters cool the land, summers warm it, and spring and autumn fill the spaces between with transitions that allow life to adapt, flourish, and renew itself again and again. Earth's year, 365.25 days, marks the steady orbital path the planet takes around the sun. The journey traces an ellipse so stable and reliable that life evolved to depend on its rhythm. Plants sprout, bloom, and rest. Animals migrate, hibernate, and awaken. Oceans warm and cool. Ice advances and retreats. Everything living on Earth is tied to this gentle movement, dancing with it across vast stretches of time. A person weighing 70 kilograms weighs exactly 70 kilograms here. Earth's gravity is familiar, supportive, and perfectly matched to the bodies that evolved in its pull. Bones, muscles, and balance develop to meet the downward tug of this planet. Birds ride air currents shaped by its gravity. Trees anchor themselves with roots that pull nutrients upward against it. Even the waves of the ocean respond to gravity, both Earth's and the distant pull of the moon, rising and falling in a ceaseless, calming rhythm. Looking more closely, you see continents shaped by geological forces, unlike those on any other planet. Earth is the only known world with active plate tectonics, a slow, powerful rearranging of the crust driven by heat within the mantle. These shifting plates create mountain ranges that pierce the sky, ocean trenches that sink into darkness, and volcanic arcs that build new islands. Over billions of years, continents have drifted, collided, separated, and drifted again, like immense rafts moving across a liquid interior. This geological activity recycles carbon, nurtures ecosystems, and renews the planet in subtle, life-sustaining ways. Earth's surface is a mosaic of climates and environments. Deserts glow tan and gold beneath the sun, shaped by wind and heat. Forests spread in deep green textures, absorbing light and exhaling oxygen. Polar caps glisten in white expanses, reflecting sunlight back into space and stabilizing global temperatures. Grasslands ripple in soft waves as breezes pass over them. Mountain ranges cast long shadows. Every region offers its own form of life, adapted through countless generations to the softness or harshness of its surroundings. Life on Earth exists in an astonishing range of forms, from the smallest microbes hidden beneath rocks to the largest trees reaching toward the sky. Each organism participates in the planet's intricate web. Plants gather sunlight and turn it into energy. Herbivores graze, carnivores hunt, scavengers clean. Microorganisms break down what remains, returning nutrients to the soil and sea. The balance is delicate, yet resilient, a harmony formed by millions of interacting species, living, growing, and adapting together. The oceans, especially, are worlds within a world. Beneath the shimmering surface lies an immense realm of coral reefs, drifting plankton, swirling schools of fish, and deep-sea creatures that glow in eternal darkness. The oceans carry heat around the globe, generating currents that shape weather systems, stabilize temperatures, and sustain life on every continent. Waves break softly on beaches, tides shift with the pull of the moon, and water evaporates to form clouds that drift across vast distances before falling again as rain or snow. Earth's skies form another layer of wonder. Clouds gather and disperse in endless patterns. Storms bloom, grow, and dissolve. Gentle breezes move across fields. High-altitude winds carry seeds, pollen, and moisture across continents. Sunlight filters through morning fog, creating golden halos. Rainbows appear, momentary and delicate. The sky is not just a barrier between surface and space, but a dynamic, living part of Earth's energy system, connecting land, sea, and air in continuous cycles. The presence of one moon, large compared to Earth's size, influences the planet profoundly. The moon stabilizes Earth's tilt, prevents chaotic shifts in climate, and shapes the rhythm of tides. Its soft glow illuminates night landscapes and has inspired human imagination for millennia. Without the moon's steady influence, Earth's seasons might swing wildly, its oceans would move differently, and countless forms of life might never have evolved as they did. Earth's magnetic field, generated by the movement of molten metal in its core, forms an invisible shield around the planet. This magnetic bubble protects the surface from solar radiation and charged particles streaming from the sun. When these particles interact with the field near the poles, they create auroras, shimmering curtains of green, pink, and violet light. These lights ripple across the sky in silent waves, a reminder that Earth lives within a vast and energetic universe, yet remains safely sheltered. Looking down at Earth from above, you may notice the faint patterns created by human activity. Cities glowing like constellations at night, roads tracing lines across continents, ships moving across oceans. These are recent features, appearing only in the last fraction of Earth's long history, yet they represent a species capable of self-awareness, creativity, and reflection. A species able to look back at its own world from above and understand its fragility. In spite of all its complexity, Earth maintains a gentle balance. The planet warms under sunlight and cools beneath the night sky. Water cycles from oceans to clouds and back again. Winds distribute heat. Plants breathe in carbon dioxide and release oxygen. Life constantly adjusts, finding ways to coexist even in environments that seem impossible. Through storms, droughts, eruptions, and ice ages, Earth continues to renew itself, always seeking equilibrium. From this peaceful vantage point in space, Earth appears as a place of harmony and possibility, a world perfectly balanced between too hot and too cold, too bright and too dark, too dry and too wet. It is the rare middle ground where conditions allow liquid water, stable climates, varied ecosystems, and intelligent life. Earth is, in every sense, the Goldilocks world. Not too extreme, not too barren, but just right for life to bloom in countless forms. Observing Earth from above, you may feel a gentle gratitude for its existence. The forests, oceans, mountains, and clouds form a living tapestry that has persisted through billions of years of change. Every breath of wind, every falling raindrop, every shifting tide is part of the planet's long, quiet story, a story still unfolding, shaped by both natural forces and the beings who call this world home. You remain floating above this familiar yet astonishing world, held in calm silence. The blue oceans shimmer softly. The continents glow under sunlight. Thin layers of cloud drift lazily across the horizon. Earth rotates slowly beneath you, revealing new landscapes with each passing moment. A peaceful, living sphere, suspended in a vast universe of stillness. Drifting gently through the silence of space, you approach a world that glows with a soft, rusty hue. Mars comes into view slowly, revealing itself not with the bright blues and whites of Earth, nor with the dense golds of Venus, but with muted reds, browns, and grays. Its colors resemble the tones of desert sands warmed by sunlight, a landscape shaped over billions of years by the forces of wind, frost, stone, and time. From afar, Mars appears calm, almost contemplative, a world that holds its history quietly beneath the cold sky. As you hover closer, you see that the planet is scarred by canyons, plains, and dried riverbeds. These ancient channels snake across the surface in patterns that strongly hint at a warmer past. Long ago, Mars may have been more Earth-like, with liquid water flowing across its surface, carving valleys and pooling into lakes. Today, these features lie frozen in time, like footprints from a vanished era. The rivers no longer run, but their shapes endure, etched permanently into the red dust. The Martian day is familiar, just a little longer than Earth's, lasting 24.6 hours. The sun rises and sets across pinkish skies, casting long, delicate shadows. During the day, temperatures can reach as high as 20 degrees Celsius at the equator, but when night arrives, the warmth escapes quickly into the thin atmosphere. temperatures plunge to -100 or even -125 degrees Celsius. The planet cannot hold its heat. Mars breathes warmth in and out with the turning of each day, exhaling it into the dark as quickly as it comes. The atmosphere itself is faint, made mostly of carbon dioxide. It is too thin to provide meaningful warmth, too thin to protect against radiation, and too thin to breathe. Standing here without a suit would give you only 30 seconds of survival. The air would slip out of your lungs, water in your tissues would begin to evaporate, and the cold would seize you instantly. Yet despite these dangers, the thin sky carries subtle beauty. Delicate winds lift fine dust into motion, creating soft, swirling patterns that drift across plains. If you weighed 70 kilograms on Earth, you would weigh only about 26 kilograms on Mars, the same as you would on Mercury. This gentle gravity makes movement feel light, as though each step carries you slightly farther than expected. Dust would rise slowly and fall gracefully. Leaping would feel effortless. Mars invites small, joyful movements, even though its environment remains cold and unwelcoming. Among Mars's many landmarks, none is more striking than Olympus Mons, the tallest volcano, and in fact, the tallest mountain in the entire solar system. Rising more than 22 kilometers above the surrounding plain, it dwarfs every mountain on Earth. Its slopes are gentle and broad, stretching across hundreds of kilometers. To stand on its summit would be to stand on a world within a world, a height so immense that the curvature of the planet becomes subtly visible. Yet Olympus Mons has long been dormant, its fiery past silent now beneath the cold sky. If you drift eastward across the planet, you encounter Valles Marineris, a canyon system so vast that it spans nearly a quarter of the planet's circumference. Some sections plunge more than 10 kilometers deep. The cliffs rise in jagged walls, their shadows stretching across the canyon floor like dark rivers frozen in place. This immense scar likely formed through ancient tectonic activity, perhaps when the crust stretched and cracked under forces long lost to time. The canyon reveals layers of history that stretch backward through billions of years. Dust storms shape the Martian surface with gentle persistence. Some storms are small and short-lived, lifting grains into the air like swirling sand. Others grow into enormous planetary events, covering the entire globe in a fine orange haze. During these storms, sunlight dims, temperatures drop, and landscapes vanish beneath a blanket of drifting dust. Though these storms appear dramatic, the thin air makes them gentle. They would not knock you over, even if you were caught inside one. They are whispers, not roars, shaping the land through subtle, continuous motion. Mars's polar regions shimmer in shades of white and pale blue. These caps consist of layered ice, frozen water mixed with frozen carbon dioxide. In winter, carbon dioxide from the atmosphere falls as frost, expanding the caps outward. In summer, it sublimates directly back into vapor. This seasonal breathing creates a delicate balance that thins and thickens the air throughout the Martian year, a rhythm that shapes the planet's climate in gentle, repeating cycles. Beneath the surface, far from sunlight and storms, scientists suspect that pockets of liquid water may still exist, perhaps briny, perhaps isolated, but possibly persistent. These subsurface reservoirs might hide tiny microbial life, protected from radiation and extreme cold. the idea that life may linger beneath the dust, inspires countless missions and studies, each seeking clues in minerals, ice layers, and chemical signatures. Mars may no longer host rivers and lakes on its surface, but beneath the quiet plains, it may still carry the warmth of possibility. The red color that defines Mars comes from iron oxide, rust, coating the soil and rocks. This fine dust gives the planet its familiar hue, glowing softly under sunlight and deepening in shadow. Up close, the colors vary more than you might expect. Tans, browns, and muted oranges mix with patches of gray rock and dark volcanic soil. In certain lights, the landscape resembles deserts on Earth, though colder, drier, and infinitely more ancient. Wind shapes many of the planet's patterns. Without water to move sediment, Mars relies on breezes and dust devils, tall, swirling columns of air that dance across plains, lifting fine grains into spiraling trails. These dust devils leave dark streaks behind them, temporary markings that fade over time. They remind you that even in a world so still and quiet, subtle motions continue to reshape the land. Small rocks and boulders scatter across the surface, leftovers from meteorite impacts. Because Mars's thin atmosphere does little to slow incoming objects, impacts are more common than on Earth. Craters of all sizes decorate the landscape, some eroded, others sharp and new. Each crater is a reminder of the planet's vulnerability, but also of its resilience. For billions of years, Mars has endured collisions, storms, freezing nights, and dry winds. Yet it remains poised in silent endurance. Though Mars may appear lonely, it has two small moons, Phobos and Deimos. These tiny, irregularly shaped bodies orbit close to the planet, casting faint shadows across its surface. Phobos is so close that it rises and sets twice each day, moving swiftly across the sky. Deimos drifts more slowly, its motion gentle and serene. These moons likely originated as captured asteroids, pulled gently into orbit by Mars's gravity. Their presence adds quiet companionship to this solitary world. Mars's thin skies offer sunsets unlike any on Earth. Because of the way sunlight scatters through dust and the carbon dioxide atmosphere, sunsets here glow in soft blues at the center, surrounded by warm oranges and reds. The effect is the reverse of Earth's colors. A Martian sunset is cool and calming, the sky gently shifting as the sun sinks behind distant mountains or plains. The colors linger for a while, fading slowly into the deep, dark night. In the darkness, the stars shine brilliantly through the thin atmosphere. Even during the day, with the sky a soft butterscotch color, the sun appears smaller than it does on Earth, a slightly shrunken disk glowing through the haze. At night, the clarity of the heavens offers a vast, unbroken window to the universe. Mars feels closer to the stars, quieter in its stillness, more exposed to the cosmic backdrop than the sheltered Earth. Scientists imagine Mars as a place where exile and hope intertwine. It holds the memory of oceans and rivers that vanished long ago. It holds the possibility of life hidden beneath ice. It holds landscapes shaped by ancient accidents and slow erosion. And above all, it holds silence, the kind of silence that exists only where time moves without interruption, where seasons come and go without storms of water or waves of wind to alter the surface dramatically. You float above this frozen desert, taking in its colors, its patterns, its vast plains and immense mountains. Every shape you see formed over millions or billions of years. Every ridge and channel is a message sent forward in time from a world that once knew warmth and movement. Mars is a relic of what might have been, and a quiet hint of what might still lie, hidden beneath its dust. Above the empty valleys and the towering volcanoes, Mars rests in a state of patient stillness. Its thin winds whisper across dunes. Its shadows stretch and shrink with each passing sun. And through all these motions, the planet remains calm, unhurried, and enduring. A frozen desert, but one with a warm and ancient heart. As you drift through the quiet darkness beyond Mars, a vast, luminous shape begins to dominate your field of view. It grows slowly at first, then rapidly expands until it fills your awareness with swirling colors and immense patterns. Jupiter, the largest planet in the solar system. A world so big that all the other planets could fit inside it with room to spare. Approaching Jupiter feels like approaching a living, breathing canvas of motion, painted with storms, bands, and swirling clouds that never rest. From afar, Jupiter appears striped, a pattern of alternating light and dark zones that circle the planet in smooth, continuous bands. These stripes are created by powerful jet streams, each flowing in opposite directions, wrapping the giant planet with winds that reach hundreds of kilometers per hour. The lighter zones, known as belts, rise high into the upper atmosphere. The darker zones, called bands, sink lower, revealing deeper layers of cloud. The effect is mesmerizing, like watching a massive rotating marble carved from swirling mist. As you glide closer, you begin to distinguish the cloud layers themselves. Shades of white, beige, brown, orange, and subtle reds, blending and separating across vast distances. Jupiter's clouds are made primarily of ammonia crystals, along with deeper layers composed of ammonium hydrosulfide and water vapor. Sunlight scatters through these materials in different ways, creating rich, layered colors that shift gently with time. These clouds stretch for thousands of kilometers, forming patterns that rise, twist, and dissolve in slow, hypnotic motions. A day on Jupiter is extremely short. The entire planet completes one rotation in only about 10 hours, the fastest spin of any world in the solar system. This rapid rotation stretches the clouds into the familiar striped patterns you see, giving the planet its banded appearance. It also flattens Jupiter at the poles and bulges it around the equator. If you look carefully, the planet is not quite round. Its rapid spin reshapes it, making it slightly squashed, as if the immense world were pressing outward under its own rotational force. There is no solid surface here. Jupiter is made mostly of hydrogen and helium. If you could descend into the atmosphere, you would find no boundary between air and ground. Instead, the clouds would grow denser, the pressure would increase, and the gas would gradually transform into a thick fluid. Far beneath the visible clouds lies a layer of liquid metallic hydrogen, a strange state of matter created by the intense pressure within Jupiter. This metallic liquid conducts electricity, and its motions generate the strongest magnetic field of any planet in the solar system. To imagine descending into Jupiter is to imagine falling into endless storm. The upper cloud decks are cold, around minus 145 degrees Celsius. But as you sink deeper, the temperature rises dramatically. Pressure increases to thousands of times what a human body could withstand. In the deepest layers, temperatures soar to thousands of degrees, hotter than the surface of some stars. No machine could survive the journey for long. Even imagining a descent requires stepping outside the boundaries of conventional experience. Hovering safely above the clouds, you witness the largest storm in the solar system, the Great Red Spot. This swirling oval, a deep reddish hue, is so large that Earth could fit inside it more than once. The storm has raged for at least 350 years, perhaps much longer. Winds whip around its perimeter at incredible speeds, yet the entire structure rotates slowly and steadily, like a colossal wheel turning against the spin of the planet. The color of the storm shifts over time, sometimes bright red, sometimes pale, sometimes almost fading, but it never disappears entirely. The Great Red Spot is Jupiter's signature, a visible heartbeat of atmospheric motion. Storms on Jupiter occur everywhere, not just in one place. White ovals, miniature storms compared to the red spot, but still larger than Earth's biggest hurricanes, drift calmly across the belts. Brown barges, long, dark shapes in the atmosphere, form and dissolve. Lightning flashes deep within the clouds, illuminating storms that tower higher than Everest. These storms are powered by the heat rising from Jupiter's interior. The planet emits more heat than it receives from the sun, a warm breath of ancient energy trapped from the time of its formation. The atmosphere of Jupiter is layered like a vast symphony. The upper clouds form delicate streaks, constantly reshaped by winds. Beneath them lie thicker layers of ammonia and water vapor. Deeper still, the clouds become dense and warm. Each layer moves at different speeds and directions, creating swirling vortices where bands interact. Some storms merge, others split apart. Some rise from lower levels, forming towering plumes that stretch high above the surrounding clouds. From this vantage point, Jupiter's colors appear alive. Subtle textures ripple across the belts, while eddies form spirals that drift and fade. The darker belts are turbulent zones where air descends, compresses, and warms. The lighter zones are regions where air rises and cools, creating towering cloud tops that sparkle faintly in sunlight. Watching these motions feels like watching a slow dance, intricate, complex, but always harmonious. Jupiter's immense gravity shapes its surroundings with overwhelming force. The planet's magnetosphere, its magnetic bubble, extends far into space, forming a structure larger than the sun. Charged particles trapped in this field create intense radiation belts. If you could see this magnetosphere, it would appear as a huge, invisible shield, glowing faintly with energy, stretching millions of kilometers outward. Aurorae form at Jupiter's poles, just as they do on Earth, but they are far more powerful, glowing constantly in brilliant ultraviolet light. Jupiter is surrounded by a faint ring system, though it is not as bright or dramatic as Saturn's. These rings are thin, composed of dust particles thrown into orbit by impacts on the planet's moons. They appear dark and subtle, barely visible except when illuminated from behind. They remind you that even the giant planet holds fragile, delicate structures close to its massive form. And Jupiter has moons, dozens of them, more than 90 known. 4 of these moons, called the Galilean moons, stand out like worlds of their own. Io, Europa, Ganymede, and Callisto orbit Jupiter in a steady rhythm, locked in a dance shaped by gravity. Each is different. Each holds its own mysteries, and each contributes to the dynamic environment of the Jovian system. though they are separate from Jupiter itself, their presence adds texture and story to the giant planet. Io, the innermost of the Galilean moons, is the most volcanically active body in the solar system. Its surface glows with lava lakes and erupting plumes. Europa, with its smooth, icy shell, hides a vast ocean beneath its surface, an ocean that may harbor the conditions for life. Ganymede, the largest moon in the solar system, has its own magnetic field and a complex, icy crust. Callisto, ancient and cratered, preserves the solar system's old scars. These moons, orbiting in regular resonance, exert gravitational tugs on one another, shaping tides within Jupiter's interior and amplifying its storms. Even from afar, Jupiter's gravity influences comets, asteroids, and the very structure of the solar system. It acts as a cosmic guardian, pulling in wandering objects or diverting them away from inner planets. At other times, it captures small bodies into temporary orbits or sends them outward into distant trajectories. Jupiter's presence has shaped Earth's history, altering the flow of potential impacts and protecting the inner planets from frequent collisions. Floating above Jupiter's surface, you sense its scale, not just in size, but in motion. Everything here is grand. The storms, the winds, the magnetic field, the heat flowing outward from its core. The planet is a symphony of forces and motions that extend far beyond the clouds you see. Yet despite all this activity, Jupiter radiates a strange calm. Its storms follow predictable paths. Its winds remain steady. Its rotation never slows. The giant planet moves with an ancient confidence, a reminder of the stability that massive bodies bring to the solar system. Jupiter has no solid ground, no mountains or valleys, no shores or plains. Yet the absence of these features does not diminish its presence. Instead, the planet expresses itself through the language of atmosphere, through bands, storms, waves, and currents. Each cloud formation is an expression of internal heat, rising, and solar energy interacting with it. Each swirl is a gesture, each band a boundary. The entire planet becomes a living artwork, painted on a canvas of gas thousands of kilometers deep. If you were to remain in orbit long enough to watch Jupiter's full rotation, you would see its features shift, but never truly disappear. The great red spot would glide slowly across the horizon and vanish behind the curve, only to re-emerge later. New storms would form in the belts. Old ones would dissipate. The planet would continue its dance with quiet persistence, always changing, yet always familiar. Jupiter's sheer presence offers a sense of stability. In a solar system filled with rocky worlds, icy bodies, and fragile atmospheres, Jupiter stands as a giant guardian, immense, powerful, and timeless. Its gravitational pull steadies the orbits of many objects. Its magnetic field shapes the space around it. Its energy radiates outward into the cold depths of the outer solar system. Even in the vastness of space, Jupiter feels grounded, anchored, enduring. You remain suspended above this world of storms, witnessing the vast patterns that stretch across its face. The swirling belts, the great storms, the subtle rings, and the countless moons create a celestial architecture of extraordinary beauty. In Jupiter's presence, you feel the immensity of scale, the depth of time, and the quiet power of a planet that has outlived countless changes in the solar system. The giant planet rests below you, not in stillness, but in a constant, gentle rotation, always turning, always breathing through its storms. And this immense, swirling world continues its ancient journey around the sun. carrying its colors, winds, and moonlit companions through the silent darkness of space. Far beyond Jupiter's swirling storms, a pale golden world slowly comes into view, elegant, serene, and unmistakably beautiful. Saturn appears like a jewel suspended in space, its soft hues blending into muted yellows and gentle creams. But what draws your attention first? What captures the imagination of anyone who drifts near this planet is the enormous ring system encircling it. These rings form a delicate halo that glows with a quiet, ethereal radiance, stretching outward in thin, precise lines, shaped by gravity and time. Saturn itself is a gas giant, similar to Jupiter, but lighter, less dense, and more softly colored. Its upper atmosphere reveals subtle bands of cloud, though less vivid than those of its larger neighbor. These bands move in parallel lines around the planet, shaped by winds that reach hundreds of kilometers per hour. The colors are gentle, shades of cream, buttermilk, and faint gold, blurring softly across one another, like brush strokes on a canvas made of cloud. Saturn's appearance feels not turbulent, but peaceful, as if wrapped in a calm that only enhances its grandeur. The rings, however, tell a different story. What seems from afar like a solid, continuous disk is actually composed of countless particles, fragments of water, ice, rock, and dust, ranging from the size of sand grains to chunks as large as small buildings. These particles orbit Saturn independently, forming thin layers that stretch for tens of thousands of kilometers. Some regions are densely packed, gleaming brightly as they reflect sunlight. Others are delicate, nearly transparent, where only a faint shimmer reveals the presence of ice. The entire ring system is incredibly thin. Despite spanning hundreds of thousands of kilometers across, the rings are often less than 100 meters thick. If you scaled Saturn down to the size of a tennis ball, the rings would be thinner than a sheet of paper. This fragility gives them a quiet, ephemeral quality, as though they could drift away at the slightest disturbance. Yet gravity keeps them arranged with precision, shaped by Saturn's pull, and by the small moons known as shepherd moons, which guide and maintain the structure of the rings. Saturn's rotation is fast, completing a full spin in just about 10.5 hours. This rapid rotation flattens the planet, giving it an oblate shape where the equator bulges outward. The atmosphere, though less vividly banded than Jupiter's, is still dynamic. Storms form and dissolve across the cloud tops, including the famous hexagon-shaped storm at the planet's north pole, a massive, rotating pattern unlike anything seen on any other planet. This strange geometric storm stretches thousands of kilometers across. Its six-sided structure, created by deep atmospheric waves, locked in place by Jupiter's powerful winds. Saturn's clouds are composed primarily of hydrogen and helium, with traces of methane and ammonia. In deeper layers, these gases form thicker clouds of ammonia ice and water ice. The atmosphere is extremely cold, with temperatures averaging around -178 degrees Celsius. Yet despite this cold, the planet emits more energy than it receives, a lingering warmth from its formation long ago. Pressure increases rapidly as you move downward through the atmosphere, transforming gas into dense fluid. As with Jupiter, Saturn has no solid surface, only a gradual transition from gaseous clouds into regions of increasing pressure and temperature. Descending through Saturn's atmosphere, if it were possible, would take you through layers of cloud stacked in soft gradients. The upper layers would appear pale and smooth, while deeper regions might reveal thicker, darker areas of vapor. Lightning flashes occasionally light up the cloud layers, illuminating storms that churn far below. These lightning bolts, though rare, are immensely powerful, branching through the cloud decks with sudden brilliance. But no human-built device has ever descended into Saturn's depths for long. The crush of pressure would destroy even the strongest machines. Yet, for all its immense size and deep layers, it is Saturn's rings that hold the most enchantment. Drifting near them, you would see countless ice fragments moving in long, elegant arcs. Some reflect sunlight, like tiny mirrors. Others glow faintly with the cold whiteness of frozen water. Shadows fall across the rings in soft, intricate patterns as the sun's rays strike them at different angles. From certain perspectives, the rings appear like ripples in still water, thin, delicate, and serene. The origin of Saturn's rings remains a mystery. They may be the remnants of a destroyed moon, shattered by a collision, or torn apart by Saturn's tidal forces. Or they may be leftover material from the planet's formation, fragments that never coalesced into a larger body. Whatever their origin, the rings are surprisingly young on cosmic timescales. Some studies suggest they may be only 100 million years old, forming long after Saturn itself. This youthfulness gives them an aura of transience, as if they were a temporary adornment, a fleeting decoration that may eventually fade. Within the rings are narrow gaps carved by small moons. These moons act as custodians, shaping the ring edges and guiding the particles into clean, sharp divisions. Some of these gaps are caused by orbital resonances, where the gravity of larger moons influences the motion of ring particles. Others are maintained by tiny shepherd moons, traveling within the rings themselves. Their passage creates waves, ripples, and braids, subtle features that appear like fine markings etched into Saturn's halo. Farther from the rings, Saturn's family of moons offers worlds as varied and fascinating as planets themselves. Titan, the largest moon, is cloaked in a thick orange atmosphere, rich in nitrogen. Lakes and rivers of liquid methane and ethane flow across its surface, creating landscapes eerily reminiscent of Earth's, but composed of entirely different materials. Titan's surface temperature is far below freezing, yet conditions allow for methane cycles similar to Earth's water cycle. Clouds form, rains fall, and bodies of liquid gather in basins, shaping a world both alien and strangely familiar. Enceladus, another of Saturn's moons, hides a global ocean beneath its icy crust. Geysers erupt from cracks near its south pole, spraying water vapor and organic molecules into space. These plumes feed Saturn's faint E-ring and hint at warm, hydrothermal vents deep within the moon's ocean. Scientists consider Enceladus one of the prime locations in the solar system where life could potentially exist, protected from space by kilometers of ice, and heated from below by tidal forces. Other moons, such as Rhea, Dione, Tethys, Mimas, and Iapetus, add further complexity to Saturn's system. Some are heavily cratered, preserving ancient scars. Others have smooth plains or icy fractures. Iapetus, intriguingly, displays a stark contrast between one hemisphere that is bright as snow and another that is dark as charcoal. Mimas, known for its crater that resembles the iconic Death Star from fiction, rotates quietly in orbit, carrying its own unique story of impacts and icy evolution. Every moon orbits within Saturn's gravitational embrace, shaping and being shaped by the giant planet's influence. Tidal forces stretch and compress these small worlds, creating heat in their interiors. Some moons tug on ring particles, carving shapes and patterns. Others remain distant, silent companions drifting through the darkness. Together, they form a complex ballet. Moons circling a giant, rings spanning wide arcs, all governed by ancient gravities that remain perfectly balanced. Saturn's magnetic field, while not as powerful as Jupiter's, nonetheless forms a protective bubble around the planet. Charged particles from the sun spiral along magnetic lines, creating auroras at Saturn's poles. These auroras glow in ultraviolet light, invisible to the naked eye, but stunning through instruments that can detect them. They shimmer silently in the upper atmosphere, illuminated by currents of energy flowing through the magnetic field. The effect is gentle and calming, a reminder that even giants experience moments of subtle beauty. With such vastness, Saturn's presence in the solar system is one of quiet authority. It has guided countless asteroids and comets, pulling them into harmless orbits or deflecting them away from the inner planets. Its gravity influences Jupiter and shapes the collective behavior of the outer worlds. In a system where many small bodies wander unpredictably, Saturn provides a stabilizing force, a grand, slow-moving anchor in the cold depths of space. From your perspective, drifting gently above this world, Saturn feels like a place of harmony. The rings drift around the planet in wide, graceful circles. The cloud bands shift slowly, their colors blend in with softness. The moons follow their paths in unbroken rhythms, each with its own pace. Nothing seems rushed here. Movements unfold across hours, days, or decades. The planet embodies patience, balance, and quiet elegance. The light of the distant sun glints across the rings, casting delicate shadows onto Saturn's upper clouds. As you move slightly in your vantage point, the rings change their appearance. Sometimes they glow with white brilliance. Sometimes they appear faint and ghost-like. When viewed edge-on, they become nearly invisible, a razor-thin line that disappears into the blackness. This shifting perspective is part of Saturn's beauty. It never looks quite the same from one moment to the next, yet remains unmistakable. Saturn's immense size, second only to Jupiter, gives it a sense of silent strength. Yet it is the rings, fragile and intricate, that inspire the deepest sense of wonder. Unlike the storms of Jupiter or the volcanic heart of Io, Saturn's beauty lies in structure, in arrangement, in delicate order. It is a place where the balance of gravity has sculpted a masterpiece over millions of years, where each particle finds its place, contributing to a vast, harmonious whole. You continue to drift above this world of pale gold and shimmering ice, watching the rings create gentle lines across the darkness. The cloud bands shift with slow purpose, and the moons cast their faint shadows onto the planet below. Saturn turns steadily on its axis, carrying its rings and its family of moons with tender, unbroken motion. In this stillness, you feel the calm of a planet that has endured for billions of years, elegant, ancient, and serene. Drifting farther into the outer solar system, you approach a world that glows with a cool, tranquil blue. Uranus appears as a smooth, softly colored sphere, its gentle hue created by methane in its atmosphere. Unlike Jupiter and Saturn, which display lively bands and swirling storms, Uranus wears a calm, minimalist face. Its clouds lie hidden beneath a haze so uniform that the planet looks almost perfectly featureless from afar. A serene, icy orb, suspended in the vast quiet of space. One of the most striking aspects of Uranus is its orientation. The entire planet is tipped over on its side, rotating almost horizontally. Its axial tilt is about 98 degrees, so extreme that Uranus essentially orbits the Sun lying down. Where other planets spin upright, Uranus rolls like a gentle blue marble along the path of its orbit. This unique tilt results in seasons that last for decades. For nearly half of its 84-year orbit, one pole faces the Sun continuously, bathing in unending daylight, while the opposite hemisphere remains in darkness. Because of this sideways rotation, Uranus has an unusual day-night cycle. At the equator, the Sun rises and sets in a more familiar pattern. But near the poles, the Sun can hang in the sky for years at a time, creating long, slow transitions from day to night and back again. Imagine a sunrise that lasts months, or a sunset that unfolds gradually over an entire season. On Uranus, time moves differently, creating rhythms of light and shadow that feel dreamlike and abstract. Like Jupiter and Saturn, Uranus is a gas giant, though more accurately, it is known as an ice giant. The planet's atmosphere contains hydrogen, helium, and methane, but deeper within are layers of water, ammonia, and methane ices. Below this icy mantle likely lies a deep ocean of superionic water so compressed and heated that its molecules break apart, forming a strange, electrically conductive fluid. This exotic material cannot exist naturally on Earth, yet it forms a significant portion of Uranus's interior, swirling under enormous pressure. Uranus has no solid surface. Descending into the atmosphere would be like sinking into a cold, dense fog that gradually becomes thicker and more pressurized. The upper clouds hover around -224 degrees Celsius, some of the lowest natural temperatures found anywhere in the solar system. At this extreme cold, molecular motion slows dramatically. Winds still blow, and storms still form, but they unfold with a slow, graceful energy that contrasts sharply with the raging tempests of Jupiter. Despite its tranquil appearance, Uranus experiences weather patterns that are subtle yet powerful. In the past few decades, telescopes and spacecraft have revealed bright storms forming temporarily in the planet's upper atmosphere. These storms, though faint, represent upwellings of methane ice crystals, rising from deeper, warmer layers into the visible haze. The storms drift across the planet in slow procession, their wisps stretching and fading as Uranus turns beneath them. The planet's winds can reach speeds of over 900 kilometers per hour, astonishing for a world that appears so still. These high-speed winds flow along latitudes shaped by internal heat and the planet's unusual rotation, but Uranus emits very little heat compared to other gas giants. Where Jupiter and Saturn radiate more energy than they receive from the Sun, Uranus seems unusually quiet internally. Scientists are not certain why. Perhaps some ancient event, like the giant collision that tipped it on its side, released internal heat long ago, leaving the planet to cool rapidly afterward. Whatever the cause, Uranus presents an enigmatic blend of strong winds and weak internal energy. a puzzling combination. When sunlight reaches Uranus, much of it is absorbed by methane, giving the atmosphere its blue-green tint. The upper haze layers scatter the remaining sunlight, softening the planet's appearance to a gentle glow. From your vantage point, Uranus appears like a peaceful lantern drifting in space, muted, distant, and elegant. The way it reflects light is calming, as though the world itself is wrapped in a quiet, cold tranquility. Beyond its visual charm, Uranus possesses a faint but beautiful ring system. These thin rings are darker and more subtle than Saturn's brilliant arcs, composed mostly of microscopic dust and small chunks of rock. The rings are arranged in narrow, sharply defined bands, some only a few kilometers wide. They appear almost invisible unless viewed from the correct angle, where sunlight catches their edges and reveals their delicate structure. Despite their fragility, these rings orbit with stable precision, shaped by small moons that guide their paths. Uranus's magnetic field adds yet another layer of peculiarity. Unlike Earth's magnetic field, which aligns closely with its rotational axis, Uranus's field is tilted dramatically, not only off-center, but angled by about 59 degrees from the axis of rotation. This creates a magnetosphere that twists and tumbles in complex ways as the planet spins. Charged particles trapped in the field spiral along irregular paths, forming auroras that shimmer near the poles, but shift unpredictably. These auroras glow faintly, often in ultraviolet light, shimmering like soft curtains against the dim atmospheric haze. Orbiting around Uranus are 27 known moons, each with its own quiet character. Many of them are named after characters from the works of Shakespeare and Alexander Pope, a poetic tradition that suits the planet's serene appearance. Titania and Oberon, the two largest moons, are icy worlds covered in craters and ancient valleys. Their surfaces show signs of tectonic activity long ago, when internal heat may have cracked their icy crusts and allowed material to flow from within. Ariel, one of the brightest of Uranus's moons, displays canyons, fractures, and smooth plains created by resurfacing processes. It is a world shaped by ice rather than rock, with features softened over time by slow glacial movements. Umbriel, in contrast, is dark and mysterious, its surface coated in darker material that absorbs sunlight, making it one of the least reflective bodies in the solar system. Miranda, perhaps the most intriguing moon, is small but extraordinarily varied. Its terrain looks almost stitched together. Enormous cliffs, smooth expanses, and strange patchwork formations suggest a violent past of impacts and internal upheaval. Each of these moons orbits within the tilted plane of Uranus, following the planet's sideways orientation. As Uranus rolls around the sun, its moons follow along, producing unusual eclipse patterns, alignments, and shadows. Their orbits create a cosmic choreography shaped by ancient gravitational resonances. Drifting above them, you see the graceful arcs of their paths, each moon moving steadily, quietly, around the pale blue giant. The dark surfaces of some moons contrast against Uranus's gentle glow, creating scenes of quiet beauty. When sunlight strikes their icy crusts, it reflects with a faint sparkle, like frost, catching dawn light. When they pass into Uranus's shadow, they fade into near invisibility, becoming silhouettes against the darkness of space. Their presence feels almost meditative, a slow, deliberate movement through a serene environment where nothing is rushed. Because Uranus orbits so far from the sun, its environment is cold beyond earthly comprehension. Sunlight here is faint, only a small fraction of what reaches Earth. Days unfold softly, without harsh brightness. Nights stretch long, blending smoothly into one another. Light moves gently across the planet's clouds, revealing subtle shifts in color. In this distant region, warmth feels like memory rather than sensation, and the cold becomes a quiet companion. Yet even in this cold, Uranus exudes a sense of calm resilience. Its storms, though faint, move with purpose. Its winds flow steadily. Its rings hold their structure with delicate precision. Nothing appears chaotic. Instead, Uranus presents a picture of quiet order, shaped by gravity and the slow passage of time. It is a place where changes unfold across centuries rather than minutes, where stillness is not emptiness but stability. Approaching the planet, you sense its vastness. Though smaller than Jupiter and Saturn, Uranus is still enormous compared to Earth. A world of immense depth, layered atmospheres, and internal oceans hidden far below. If you could hover in its upper clouds, the horizon would curve gently around you, revealing a boundless dome of pale blue. Everything below would be soft, hazy, and opaque. Everything above would open into deep black, sprinkled with the faint glimmer of distant stars. The silence here feels different from the silence near the inner planets. It carries a depth shaped by distance. The sun is a small, pale disk, offering a gentle glow rather than a bright shine. The energy of the solar system feels muted, softened by the vast gulf between Uranus and the inner worlds. Time seems to stretch, each moment drifting comfortably into the next, without urgency. Uranus's isolation gives it a contemplative presence. It rotates quietly, tipped on its side. It moves along its distant orbit with slow patience. Its moons follow steady paths. Its rings hover in thin, elegant lines. And all of this unfolds in a space where sunlight is faint, winds are cold, and changes occur in slow, graceful patterns. Suspended above Uranus, you take in its subtle colors, its tilt, its faint storms, and its peaceful rings. The planet does not demand attention. It invites you to observe gently, to appreciate its quiet beauty, to notice details that only appear with patient watching. Uranus is a world that speaks softly, yet profoundly, offering its calm presence to the silent reaches of the solar system. Farther from the sun than any other major planet, Neptune emerges slowly from the darkness, a distant orb of deep, tranquil blue. The light that reaches this world is faint, only a small whisper of the warmth that shines on Earth. Yet Neptune glows with its own quiet intensity. Its color is rich and saturated, a deep azure created by methane absorbing red light and scattering blue. From where you drift, Neptune looks serene and mysterious, like a cold ocean suspended in space, endlessly turning beneath the dim light of the faraway sun. Neptune is an ice giant, similar in composition to Uranus. Its atmosphere contains hydrogen, helium, and methane, along with deeper layers of exotic ices. Yet Neptune is more dynamic, more expressive, and more animated than its pale blue neighbor. Hidden heat from within the planet drives powerful storms and atmospheric motions, creating patterns that shift over days rather than decades. Though sunlight here is weak, Neptune seems full of life. Not biological life, but the restless life of winds, clouds, and energy. As you float closer to the planet, you begin to see subtle streaks of white clouds traversing its surface. These clouds, made of methane ice crystals, stretch across the blue background like narrow brushstrokes of frost. They drift with the wind, sometimes circling the planet completely. Their movement is smooth, graceful, and hypnotic. Below them, deeper clouds rise and fall in slow cycles, shaped by internal warmth that radiates outward from Neptune's core. Neptune is home to the fastest winds in the solar system. Despite receiving little sunlight, the planet's atmosphere produces wind speeds that can exceed 2,100 kilometers per hour. These winds race across the globe in massive jet streams, circling the planet in bands that remain invisible from afar. If you could hover safely above Neptune's clouds, you would witness storms swirling with incredible speed, their pale edges stretching across thousands of kilometers. Yet from a distance, all this movement blends into a calm, unified blue, a paradox of intensity and serenity. One of Neptune's most captivating features is the Great Dark Spot, a storm similar in scale to Jupiter's Great Red Spot, though far more ephemeral. When first observed, it appeared as a wide, shadowy oval with swirling white clouds along its edges. But unlike Jupiter's centuries-old tempest, Neptune's Great Dark Spot vanished within just a few years. New dark spots form occasionally, shifting positions and sizes, emerging from deep within the atmosphere before fading again. These storms rise and dissipate like whispered breaths, brief expressions of the planet's inner energy. Neptune's day lasts about 16 hours, a rapid rotation that helps stretch its clouds and storms into long, sweeping patterns. The combination of fast rotation, internal heat, and complex atmospheric flows creates an environment of continuous motion. Even in this distant, frigid region of the solar system, Neptune's atmosphere refuses stillness. It is a world where energy rises from within, rather than arriving from the sun, where hidden warmth shapes the visible clouds, and where the cold only sharpens the clarity of the planet's patterns. The upper atmosphere is intensely cold, around minus 220 degrees Celsius. Yet beneath these frigid clouds, the deeper layers grow warmer, pressured by immense weight. Scientists believe that Neptune, like Uranus, may contain a deep ocean of water, ammonia, and methane ices. Deeper still, extreme pressures might create a form of water known as superionic ice, where oxygen becomes locked into a solid lattice, while hydrogen atoms flow freely, conducting electricity. This strange, exotic state of matter forms a vast, hidden ocean, unlike anything found on Earth. Neptune's magnetic field is highly tilted and offset from the planet's center, creating a magnetosphere that twists and turns as Neptune rotates. Charged particles spiral through this magnetic field, sometimes creating auroras near the poles. These auroras glow faintly, shimmering in invisible wavelengths, dancing gently in the upper atmosphere. The faintness of Neptune's light makes these auroras difficult to observe directly, yet they offer a quiet reminder that even in the cold, distant outskirts of the solar system, energy continues to flow and interact. Neptune is circled by a delicate system of rings, far fainter than Saturn's, but still beautiful in their own subdued way. These rings are narrow, dark, and dusty, composed primarily of small particles coated with organic compounds. Some sections of the rings appear clumpy or arc-shaped, held together by gravitational interactions with small moons. These arcs remain stable despite their fragility, creating intricate patterns that orbit with steady rhythm around the planet. Accompanying Neptune are 14 known moons, each with its own quiet story. The largest and most remarkable of these is Triton, a moon unlike any other in the solar system. Triton orbits Neptune in a retrograde direction, meaning it moves opposite the planet's rotation. This suggests that Triton was once a wandering object, perhaps a dwarf planet, captured long ago by Neptune's gravity. Its surface is icy and reflective, marked by strange, smooth plains and dark streaks created by geysers that erupt from beneath the crust. These geysers on Triton eject nitrogen gas into space, carrying tiny particles with them. The material settles back onto the surface, creating patterns shaped by winds and the moon's weak gravity. Beneath Triton's icy crust, scientists suspect a liquid ocean may exist, warmed by tidal interactions with Neptune. If such an ocean exists, it could provide conditions suitable for microbial life, another quiet possibility hidden in a distant moon of a distant planet. Other moons of Neptune vary greatly in shape and size. Some are small and irregular, orbiting close to the planet. Others drift farther away, their paths shaped by ancient collisions or gravitational captures. These moons circle Neptune in orbits that tilt, shift, and wobble slightly due to the planet's unusual magnetic and gravitational fields. Together, they form a quiet constellation around Neptune, each moving with slow precision through the deep, cold dark. The sunlight that reaches Neptune is faint, arriving with only about 1/1000th of the strength it carries at Earth. Days here are soft, dim, and muted. Shadows fall gently across the clouds, and light diffuses into pale gradients. The sun appears as a distant, small disk, bright enough to be seen clearly, but far too small to warm the atmosphere significantly. The cold that envelops Neptune is ancient and persistent, yet not absolute. Hidden heat from the planet's interior continues to drive motion, creating a balance between cold above and warmth below. Floating above Neptune, you may feel a profound sense of distance. This is a world so far from the sun that the familiar rhythms of Earth, seasons, warmth, weather, day-night cycles, feel like memories rather than sensations. Here, the solar system stretches into a vast, quiet expanse. The planets lie far apart, separated by immense intervals. Neptune's orbit takes 165 Earth years to complete. Generations pass before the planet returns to the same position around the sun. Time flows differently at this distance, slow and broad, measured in centuries rather than years. Yet despite this isolation, Neptune feels alive. Its storms rise and dissolve with surprising speed. Its winds race faster than winds anywhere else. Its clouds shift in delicate choreography, painting the planet with patterns that change every day. Neptune radiates more internal heat than Uranus, generating a faint warmth beneath its icy clouds. This internal energy reveals itself in the planet's restless atmosphere, the churning, the shifting, the swirling blue tapestry that continually renews itself. The deep blue color of Neptune is part of its allure. It feels ancient, yet youthful, cold, yet vibrant. The color is rich, calming, and endlessly deep, inviting your gaze to linger. In its stillness, the blue seems bottomless, as though the planet were an ocean without end. The faint, white clouds drifting across the surface enhance this impression, resembling breaking waves or streaks of foam carried on a gentle wind. As you hover above Neptune's atmosphere, you may notice that the planet's motions, though invisible from afar, create a soft hum of energy in your perception. Jet streams glide across latitudes. Small storms swirl in the belts. Larger tempests emerge from within and fade into the haze. Everything moves, but nothing seems hurried. Neptune's storms are swift, but the planet's deeper rhythm remains calm, quiet, and measured. The emptiness surrounding Neptune is vast, yet comforting. Beyond this world lies the Kuiper Belt, a region of icy bodies, dwarf planets, and ancient fragments that orbit even farther from the sun. But here, near Neptune, the darkness feels peaceful. The planet glows softly, its faint rings encircling it like pale shadows. The moons drift slowly in their orbits, casting gentle traces of light. Nothing disturbs the quiet. From this vantage point, Neptune offers a lesson in contrasts. Powerful winds beneath a serene exterior, deep internal heat beneath icy clouds, rapid storms beneath a calm blue surface. It is a world of hidden depths, a place where energy and tranquility coexist in beautiful harmony. Neptune's presence brings a sense of peaceful strength, not as imposing as Jupiter, not as ornate as Saturn, but deeply calming in its own elegant simplicity. As you float above this cold, distant world, you see the full sweep of its atmosphere, a vast, rotating sphere of blue, glowing softly against the blackness of space. The planet turns steadily, carrying its clouds, storms, rings, and moons with it. And the universe remains silent around it, listening to Neptune's quiet, endless motion. Far beyond the orbits of Neptune and the great gas giants, in a region where sunlight fades into a dim glow, a small, icy world drifts quietly through the darkness. Pluto appears not as a grand sphere like Jupiter or Saturn, nor as a pale blue orb like Uranus and Neptune, but as a soft, muted globe of whites, browns, and delicate pinks. It is a world of frost and frozen plains, of mountains carved from water ice, and of shadows that stretch long beneath a distant sun. In this remote place, time feels slow, measured in centuries rather than days, and silence settles like snowfall across an endless expanse. Pluto is a dwarf planet, one of many icy bodies that inhabit the outer reaches of our solar system. Its orbit is long and elliptical, carrying it from relatively closer regions to far more distant ones as it completes a single revolution around the sun in about 248 Earth years. During its closest approach, a faint atmosphere of nitrogen forms above its surface, lifted by late winter sunlight. But as Pluto drifts outward again, the thin atmosphere collapses, freezing and falling back to the ground like invisible frost. Seasons here last for decades, shaped by the world's extreme tilt and elongated path. Despite its size, smaller than Earth's moon, Pluto holds surprising geological complexity. Its surface is a patchwork of terrains, bright nitrogen ice plains, dark equatorial regions coated in organic molecules, and towering mountains rising as high as the Rockies. These mountains are made of water ice, frozen so solid that it behaves like rock. They cast long, cold shadows across the plains, revealing ancient formations that have stood unmoving for millions of years. Yet not everything on Pluto is ancient. Some areas appear young, smooth, and freshly resurfaced, suggesting ongoing processes far beneath the crust. One of the most striking features of Pluto is Sputnik Planitia, a vast, heart-shaped plain composed of nitrogen ice. This feature reflects sunlight brightly, giving Pluto its characteristic pale glow. The plain lies within a deep basin, and is divided into large, polygonal segments created by convection, frozen nitrogen slowly rising and sinking in patterns reminiscent of boiling water, though occurring on timescales stretching across centuries. These motions speak of internal heat, of gentle movements within the ice that reshape Pluto's surface in the quietest ways imaginable. Along the edges of this frozen heart lie rugged cliffs and mountain ranges, marking boundaries between different kinds of terrain. Some regions are so heavily cratered that they preserve records from billions of years ago. Others are almost entirely free of craters, indicating periods of resurfacing driven by the movement of volatile ices. Pluto's surface is a mixture of youth and age, of memories preserved and memories erased, shaped by a rhythm of slow, icy renewal. The temperature on Pluto is unimaginably cold, around -229 degrees Celsius. In this deep freeze, nitrogen, methane, and carbon monoxide form crystals that cover the surface like frost. The air is thin, composed mostly of nitrogen with traces of methane. A person could not survive here for more than a moment. The atmosphere is so delicate that even a small disturbance would scatter it. Yet sunlight still reaches this distant world, its faint rays reflecting off icy plains and casting a gentle glow across the landscape, a reminder that even at the edge of the solar system, the sun's presence persists. A 70-kilogram person would weigh only about 4.5 kilograms on Pluto. Walking here would feel like moving in slow motion, each step lifting you with quiet ease. A small hop could carry you significant distances. The world's weak gravity gives it a softness, almost a dreamlike quality, as though the planet barely holds onto its own surface. Dust and ice particles settle slowly. Shadows drift unhurried across the ground. Everything here feels light, delicate, and unbound. Pluto has 5 known moons, each orbiting in harmony around the dwarf planet. The largest and most remarkable of these is Charon. Charon is so large relative to Pluto that the two bodies form a binary system. They orbit a point in space between them, rather than one orbiting the other. Charon's surface is rugged and varied, with deep canyons and dark regions that hint at ancient geological activity. One hemisphere displays a vast reddish cap formed from gases escaping Pluto's atmosphere and freezing onto Charon's surface, creating a soft blush of color. The gravitational relationship between Pluto and Charon is unique. They always show the same face to one another, locked in mutual tidal embrace. If you stood on Pluto, Charon would hang in the same place in the sky every day and night, never rising or setting. It would appear enormous, filling a significant portion of the horizon, glowing faintly with reflected sunlight. This eternal pairing creates a sense of companionship between the two worlds, a quiet, unbroken partnership drifting through the darkness. The smaller moons, Nix, Hydra, Kerberos, and Styx, are irregular and lightly colored, shaped by collisions and ancient sculpting by ice. They tumble unpredictably as they orbit, rotating in complex patterns rather than spinning smoothly. Their motions create a dynamic miniature system, adding subtle beauty to the space around Pluto and Charon. These moons sparkle faintly in sunlight, their icy surfaces reflecting pale glimmers like tiny celestial lanterns. Pluto's story extends beyond itself. It is one of many dwarf planets in the Kuiper Belt, a vast ring of icy objects that encircles the outer solar system. Eris, Haumea, Makemake, and hundreds of thousands of smaller bodies drift through this region, forming a distant family of frozen worlds. Each dwarf planet carries its own history, its own composition, its own quiet mysteries. Some are larger than Pluto, some smaller. Some have unusual shapes or spins. Some possess faint atmospheres that emerge briefly during their closest approaches to the Sun. Eris, slightly larger than Pluto, follows an orbit that is even more elongated and distant. Its surface is coated in methane ice, giving it a bright, reflective appearance. Haumea rotates so rapidly that it has stretched into an elongated, egg-like shape. Its surface is covered in crystalline water ice, glimmering beneath the faint light. Makemake possesses a reddish tint, its thin atmosphere appearing only during the warmest points of its orbit. Each of these worlds offers a glimpse into the diversity of icy bodies that inhabit the solar system's frontier. Beyond the Kuiper Belt lies the scattered disk, a region filled with objects whose orbits stretch far into the distant reaches of space. Some of these bodies travel such long paths that their orbital periods last tens of thousands of years. Even farther still lies the hypothetical Oort cloud, a spherical shell of icy bodies that may envelop the solar system at vast distances. Though none of these distant objects have been directly observed, their existence is suggested by the behavior of long-period comets that occasionally visit the inner solar system. In this far-off realm, light from the sun feels like a gentle memory. The sun appears as a small, bright star, still warm, still luminous, but lacking the radiance it holds near Earth. The faint light casts long, muted shadows across Pluto's icy plains. Days unfold in quiet slowness. Nights stretch long beneath a sky filled with stars that barely twinkle in the vacuum. The Milky Way shines with remarkable clarity, arching overhead like a river of light. Everything here feels spacious, calm, and infinite. Standing on Pluto's surface, if you could, you would see landscapes shaped by sublimation rather than erosion. Winds are weak, water does not flow, and the slow migration of frozen gases creates patterns on the ground. Frost recedes and returns over decades. Ice sheets shift with gentle pressure. Mountains rise as blocky masses of hardened water ice, their sides etched by slow processes rather than sudden events. The silence is absolute, broken only by the imagined sound of frost cracking under distant temperature changes. The dwarf worlds beyond Neptune are reminders of the solar system's formation, remnants of the primordial disk that once swirled around the young sun. These icy bodies were never swept into planets. Instead, they remained scattered across the outer regions, preserving ancient materials and early histories. Studying them reveals clues about the solar system's birth, about the migrations of the giant planets, and about the delicate balance of forces that shaped our cosmic neighborhood. Though small, Pluto and its companions carry a quiet grandeur. They demonstrate that size does not determine significance. Even at the farthest distances, worlds continue to evolve, to shift, to show beauty. Their presence extends the solar system outward, marking the boundary between what is familiar and what becomes interstellar space. The dwarf planets drift on the frontier, like lanterns placed at the edge of a vast night. As you drift above Pluto one last time, you see the faint sunlight reflect off Sputnik Planitia, casting a soft glow across the icy plains. Charon rests nearby, locked forever in its orbit, its dark red pole glowing gently. The smaller moons move quietly through the darkness, tumbling in slow rhythms. Beyond them lies a backdrop of distant stars, still and eternal, stretching across the deep silence. Here, at the edge of the solar system, you feel a profound stillness. The journey from the sun's warmth to this icy frontier has revealed worlds of fire, storms, oceans, deserts, and ice. Pluto and the dwarf worlds bring this journey to its quiet conclusion, not with spectacle, but with gentle calm. They remind you that even in the coldest, most distant places, beauty and mystery endure. And in this slow sweep of frozen light, the solar system opens itself to the universe beyond, extending into endless night.